Good morning and welcome to MAMU with Jarvis, and we're handling grade 10 mathematics again, and we trust it's going to be a wonderful time this morning studying mathematics. Our textbook of reference is the Essential Mathematics for SS1, and just a quick reminder here that all our videos are being uploaded into the MAMU with Jarvis YouTube page. So you do well to subscribe, to like, and to make a comment so that anytime we have new videos, you are the first person to see these videos and learn. The essence of MAMU with Jarvis is to increase the awareness of mathematics and to help students to do better in mathematics. So we will start with the class this morning by looking at indices. In our class yesterday, we had covered 25 exercises, and so today we will continue with exercise 4.4, which is on page 53 of the textbook, my reference text, Essential Mathematics. And something very important is that we will start from question 26. The reason why we are trying to solve a lot of questions while introducing the topic is that we want you to have a firm grasp of the concepts. Want to have a firm grasp of the concept. So you may want to do well to watch and rewatch the videos, because sometimes understanding comes by taking out time to look at the matter over and over again. Having said all of that, let's get down to work. So you'll notice today I have my board divided into three. It's deliberate. So we go straight ahead to the work. And question 26. What does that require of us? It says b to the power of 3 over 4 divided by what? B to the power of what? 1 over 4. So remember we said that division means what? Subtract their indices. So this will now be what? B to the power of 3 over 4 minus what? 1 over 4. What does this give you? This will give me B. Now remember from your knowledge of fraction that if the bases are the same, you just take 1 and then it will be 3 minus what? 1. So that will give you what? 2 over 4. And this invariably will give us what? B raised to the power of 1 over 2 by reducing to the lowest 10. And if you want to continue with this, you can have this to be what? The square root of what? B. All right, so that is care of question 26. What about question 27? Question 27. All right, so that's for question 26. So what about 27? In question 27, you have the square root of xy squared times the square root of x y to the power of 6 times x to the power of -2. Now, how do you handle this? Now, what is this? This is same thing as x, y, all raised to the power of 1 over 2. So x, y squared, all raised to the power of 1 over 2 times x, y to the power of 6, all raised to the power of what? 1 over 2 times 1 over x squared. I see what I'm doing. I'm applying the rules as I'm saying them. Now, the next thing you want to do, the next thing you would like to do is to now treat them individually. So this will be x to the power of half, y to the power of 2 times half, times x to the power of half, x to the power of half, y to the power of 6 times half, times x times what? 1 over x to the power of what? 2. So what do? This will cancel this. This will cancel this. So you have what? X to the power of half times x to the power of half times y to the power of 1, 3, 1, times y to the power of what? 3 times 1 over x squared. At this point, you discover that x to the power of half plus x to the power of half means you're adding their indices. So this will be x to the power of half plus half, y to the power of 1 plus 3 times 1 over x to the power of 2. I can solve this faster than this, but I want you to see the progression of what we are doing. Now this will be equal to x to the power of 1, y to the power of 4, all over x to the power of what? 2. This will give us a new description, x to the power of 1 minus 2, and what? Y to the power of what? 4, which will give me x to the power of minus 1, y to the power of 4, and this will give me what? Y to the power of 4 over x. And that will be the answer. Notice that I've taken out time to take it gradually, step by step. That will be for question 27. What about 28? In question 28, we have what? The square root of what? 5a all raised to the power of 4. Now, in handling problems in indices, you really must pay attention to what the description of each question is. Pay very close attention to what the description of each question is. So this will give me what? 5a raised to the power, all raised to the power of 4 times. This square root is what? 1 over 2. So I'll treat that immediately. And I'm going to have 5a all raised to the power of 2. At this point, I'll treat them individually now. So this will be 5 raised to the power of 1 times 2, because you know that any number written on its own is to the power of 1. And this will be a raised to the power of what? 1 times 2. And that will give us what? 5 to the power of 2, a to the power of what? 2. You can further make this, simplify this one if the numbers, if the index is not very big. And this will be 25a squared. So that takes care of question 28. Let's look at question 29. You have 0.512 raised to the power of what? 1 over 3. 0.512 raised to the power of 1 over 3. Now, this one is everything here. Don't interpret it as just this 2 raised to the power of 1 over 3. It's a whole number that is raised to the power of what? 1 over 3. How do you solve a question like this? How do you handle a question like this? How can you now handle a question like this? It's in decimal. The first thing you want to do when you're solving a problem in indices, when you have a decimal, is to change the decimal to fraction. That's a new idea we want you to see here. You do what? You change the number you're seeing here to what? Fraction. So that will give you what? 512 over 1,000 all raised to the power of what? 1 over 3. So what do you do here? There are a number of options you can apply here. For me, I will advise you to reduce to the lowest term. Why? Because you'll be applying a previous knowledge you had gathered. So reduce to what? The lowest term. So how do you do that? You discover that 4 can conveniently divide this number, you get 250. 4 can conveniently divide this number, you have 128. I hope I'm right with that. 2 can divide this number, you have what? 125. And 2 can divide this number, you have what? 64. So what does that give you? That will give you 64 over 125, all raised to the power of what? 1 over 3. Now, at this point, we see when you're solving questions in indices, understand that the examiner's objective is not to try to confuse you, but to help you gain mastery. Come again. remember that the examiner or the instructor's paradigm in handling this topic is to give you or help you gain mastery. So I'm saying 1/3 here. It means that the number in here, I need to think of a number that when I multiply 3 times, I'm going to get what? 125. And when I multiply 3 times, I'm going to get 64. If you've done your work very well, you discover that 4 multiplied 3 times over 5 multiplied 3 times will give me these respective numbers I have here. And that will be raised to the power of 1/3. At this point, I will treat them separately. I'm going to treat them separately. And when I do that, I'm going to get 4/5 as my answer. So that answer will be 4/5. Okay, so let's go to question 30. Now in question 30, you have 1,000/8 all raised to the power of 1/3. Now, you will notice here that in this question, there are 2 ways you can solve this question. There are 2 ways you can solve this question. You can decide to reduce to the lowest term before you apply this, or you could just look at getting out the, what do you call it? Try to get out a number that will multiply, that you can multiply 3 times to get 1,000, and a number that you can multiply 3 times to get it. But my counsel to you in this question is, it is better in this setup to look for the number that you will multiply to get, multiply 3 times to get 1,000, and a number that you multiply 3 times to get it before you reduce to the lowest term. You'll be faster. So going with that counsel, this will be simply be what? 10 raised to the power of 3 over 2 raised to the power of 3, all raised to the power of 1/3. And this will be equal to what? 10 raised to the power of 3 times 1/3, all over 2 raised to the power of 3 times 1/3. And what does that give you? That will simply be what? 10/2, which will be 5. So you need to be very flexible in your thinking. Try to be very, very, very flexible. Flexible, don't be too rigid, because sometimes a rule may work best when you use it in a particular way than when you use it in the way that you think it ought to work. That is a conventional way. So there's no convention when it comes to solving problem. You are driven by one thing. You need to get the job done as quickly as possible. All right. Now that's for 30. So let's go to 31. For question 31, you have 729/64, all raised to the power of 1/6. Now, this is what the problem is trying to show you here. Think of a number such that when you multiply that number 6 times, you're going to get what? 729. Now, remember that we are taught you rules of divisibility. What is the prime number that can divide 729? 7 plus 2 is what? Is 9. 9 plus 9 is what? 18. Meaning that this number is divisible by 3 and by 9. So I can say that it is 3 to the power of 6. You can test it. It's my thought, but you can test it. 3 times 3 times 3 times 3 times 3 times 3. 3 times 3 is 9, 27, 81, 243, and what? 729. So you see that like I told us before, the objective is to help you progress gradually in your work. Divided by, I'm looking at 64. What's the prime number here? It is 2 to the power of 6. I check again. There is something we call trial and error in maths, and doesn't make you an inferior student or less intelligent. Trial and error helps to expand your thinking. You try, okay, this one works. Okay, Sometimes as you try the principle, it may not work. Doesn't mean it's wrong, but just to help you, okay. You must explore. That's the exploration aspect of maths. You must be able to explore, not be afraid to make a mistake once in a while. Right? So that will be all raised to the power of what? 1/6. What does this give you? This will give me 3 raised to the power of 6 times 1/6, all over 2 raised to the power of 6 times 1/6. So what's the final answer here? The final answer here will be what? 3/2. I told us before that we're not concerned with mixed number or whatever. We're just concerned with what the outcome is, because we want to see how well we're able to use our knowledge of indices. So that's 31. Let's look at 32. In question 32, you have 36/25, all raised to the power of 1/2. Now, when you are given a problem, try to look at the denominator and split the numbers with respect to that. The denominator there is already suggesting to me that what I need is 2 numbers. Look at it. 2 means you need 2 numbers you can multiply to get this. And I know this will be 6. I know this will be 5. So you see that without doing any work, any serious work, I'm getting my answers. That's the objective. Now this will be equal to what? 6 raised to the power of 2 times 1/2, all over 5 raised to the power of 2 times 1/2. With relevant calculations, your answer becomes what? 6/5. So that's for question 32. So what about question 33? You're told 27/8, all raised to the power of 1/3. Look at what's the denominator part of this index is 3. So you need to look for a number, a prime number, or a factor such that when you multiply that number 3 times, you're going to get what? 27. Obviously, that will be 3. Multiply 3 times over these 2, multiply 3 times, all raised to the power of 1/3. And that will give you what? Oh, sorry, let's not cancel yet. Some of us might not be used to that yet. So that will be 3 raised to the power of 3 times 1/3 divided by 2 raised to the power of 3 times 1/3. And that will be equal to what? 3 raised to the power of 1 over what? 2. So the answer is what? 3/2. So let's go to question 34. In question 34, we have 81 raised to the power of -0.25. Okay, let's allow us to catch our breath a little. All right, let's continue. So in this question, look at this carefully. Your first task is to convert this to what? Fraction. So what is 0.25? This will be what? 25/100. And that will give you 1/4. 5 here 5, 5 here 20, 5 here 1, 5 here 4. So that's 1/4. So invariably, this one means what? 81 raised to the power of -1/4. So you need to look for a way to, you need to look for a number that you multiply 4 times to get 81. That number obviously is 3. So 3 multiplied 4 times, all raised to the power of -1/4. Now notice that I'm saying the negative, but I'm not placing emphasis on the negative. I've told us in mathematics, there are certain things you need to be very careful about. You need to be careful how you handle negative. There are 2 ways to handle negative in a problem. You either handle it first or you handle it last. In this setup, it is best to handle negative last. It will be a lot of relief for you to handle negative last. There are certain scenarios where you must handle negative first. So I'll show you. That's why I said the challenge we've had in our study of maths up to this point is that we worked with a paradigm where you were just told to solve problems. No, there is a football aspect of solving maths where you really need to interact with the knowledge. So my approach to teaching math is to help you interact, know why certain decisions are made, so that when you are on your own, you can then make decisions for yourself and take responsibility for those decisions. Right? So with this, you're going to have that this will be what? This will cancel this one, this will cancel this one. 3 raised to the power of -1. And by our concept of what? Reciprocal, this becomes 1/3. And that takes care of that problem. All right, so let's quickly clean this one off. So 35. In question 35, we have 54/16 all raised to the power of -2/3. Now, this is one where you really have to be very, very careful. This is one question where you really have to be very, very careful. Now, if you look at 54 and 16, they are both even numbers. And from your elementary knowledge of maths, what do you know? You know that you can reduce to the lowest term. Is that not? So in this setup, reduce to the lowest term first. And that will give you what? 2 go here, 8. 2 go here, 27. So you have to be very observant when you're solving problems. And that will give you 27/8 all raised to the power of -2/3. At this point, you need to deal with the negative. Now, I told you that there are situations where you deal with the negative first, and then you deal with the negative last. You need to reduce to the lowest term first, but that is top priority. If you're solving a problem, by the time you follow me with MAMU, by the time you follow MAMU with Jarvis for the next 1 year, you will discover that your approach to maths will be different. A lot of things you've been told in maths were all fables. Math is simpler than you can imagine. I won't lie, there is work, but it's simpler than you can imagine. Just the way you play your computer games and things like that, there's something that excites your imagination. That's what I've tried to bring in teaching you how to solve mathematical problems. So look at decision making. A student once asked me, "Uncle, what's the essence of maths?" I'll tell you the essence of studying maths. One reason: decision making. And that's why you discover that anybody who's good at maths will usually excel in any sphere of life. Because why? Decision-making strength lies in the competence of a mathematician. All right, so with that, we can continue. This will give us what? This negative will cause a turning effect, to cause this to toggle. So this will turn, it will turn the numerator to denominator and turn the denominator to what? Numerator. So this becomes what? 8/what? 27, all raised to the power of what? 2/3. The next thing you do is to consider the denominator. Look at the denominator, is what? 3. So you need to think of a number such that you multiply it 3 times, you will get what? 8. You think of a number so that when you multiply it 3 times, you get what? 27. And very simple, those numbers are going to be what? Prime numbers. That's why I said that indices works on the foundational thought of what? Prime numbers. So if you don't know your prime numbers very well, you may want to go back and look at this concept very well. So that will give you 2 multiply 3 times over 3 multiply 3 times, all raised to the power of what? 2/3. With that said, this will give you what? 2 raised to the power of 3 times 2/3, treating them individually now. All over 3 raised to the power of 3 times 2/3. And what does that give you? This will cancel this, and this will give you 2 raised to the power of 2 over this will cancel this, and that will give you 3 raised to the power of 2. A very interesting observation I want you to make at this point: when solving problems, take the problems little at a time. Mistakes are minimal when you take problems a little at a time. All right, so this will give you what? 2 to the power of 2 means multiply 2 twice, and that will be 4. 3 to the power of 2 means multiply 3 2 times, and that'll be what? 9. So our final answer is what? 4 over 9. All right. Let's give us a minute or two to catch our breath. In question 36, you have 81 over 36, or raised to the power of what? -1 over 2. Now in this question, you need to take care of the negative. The negative will cause a tumbling effect here, a turning effect. And this will give me what? 36 over what? 81, all raised to the power of half. Now the next thing you do is to try to look out for a number you multiply twice to get 36, a number you multiply twice there to get what? 81. So this will give me 6 multiplied twice, all over 9 multiplied twice, all raised to the power of what? Half. Is that clear? And that will mean that this will be what? 6 raised to the power of 2 times half over 9 raised to the power of 2 times half. So what does that give you? That will give you 6 over 9, which you can reduce to the lowest term to give you what? 2 over 3. Are you seeing that? So the final answer becomes what? 2 over 3. Now 37. In question 37, you have 18 over 50, all raised to the power of -1 over 2. If you look at this carefully, now let's assume in the exam you did not see the, let's assume in the exam you had seen the table first. Okay, so let's do the table first. Because sometimes in the exam setup, what you are seeing may be different from what you would have seen if you were relaxed. The next thing you will notice is that both numbers are even. You must consciously notice this. Both numbers are what? Even. So you can cancel out 9, 25. And that will give you what? 25 over 9, all raised to the power of what? 1 over 2. So what's the next thing you do? You look for numbers such that when you multiply them, you multiply this number twice. Why is the consideration twice? Because of the denominator of the index. So 5 multiplied twice over 3 multiplied twice, all raised to the power of half. What does that give you? That will give you what? 5 raised to the power of 2 times half over 3 raised to the power of 2 times half. What does that give you? That will give you 5 over 3. And that becomes your final answer. You see that these things are basically, or they are basic repetition. The whole idea is to ensure that you are strengthening. That's what the examiner or the man who has written this book has tried to do. Strength, practice, repetition. That's how you build strength and stamina. So 38, in question 38, you have 2y raised to the power of half times 4y raised to the power of -2.5. I always advise students, the first thing you need to do in this setup is to deal with this decimal. It's always best we work with our index being an improper fraction, either a fraction or an improper fraction. So that said, this will be 2y raised to the power of half times 4y raised to the power of -2.5 is same thing as 2.5, which is what? 5 whole number over, that's 5 over 2, sorry about that, 5 over 2. So that will be what? 5 over 2. Are you seeing that? Now, what's the next thing you do? Look at 2. 2 can multiply 4. So that will be 2 times 4 times y raised to the power of half times y raised to the power of negative 5 over 2. So this one is set to, this will be 8, y raised to the power of half minus. Why is it minus? Because this one is minus. Originally, if you were multiplying, you would have added, but because this is negative, it's same thing as minus. Plus times minus. I think I did a very extensive video on this aspect of maths, and I hope we've spent our time to watch that. And that will give you what? 5 over 2, which will now be 8. Why? The bases are the same. 1 minus 5 is what? Negative 4. So that will be negative 4 over 2. And that will be 8 y raised to the power of negative 2, which you can say is, you can say the answer is what? 8 over what? Y squared. Okay? So question 39. It says 0.064 raised to the power of what? Negative 1 over 3. Remember we said that the first thing you need to do is to try to convert this to what? Fraction. So this will be equal to what? 64 over 1000, all raised to the power of negative 1 over 3. What's the next thing you do? Toggle this. That'll be what? 1000 over 64, all raised to the power of 1 over 3. Next thing, think of a number you multiply 3 times to get 1000. Think of a number you multiply 3 times to get what? 64. And that will simply be what? 10 raised to the power of 3 over 4 raised to the power of 3. Everything raised to the power of 1 over 3. And that will give you what? 10 raised to the power of 3 times 1 over 3 divided by 4 raised to the power of 3 times 1 over 3. You can cancel out. You can cancel out. And your final answer will be 5 over 2. Okay? So that's for question 39. So let's see question 40. Question 40. In question 40, you have 1 over 16, all raised to the power of what? Half. Now, remember we said that 1 raised to the power of anything is what? That thing. So for this, I would just advise you to say 1 raised to the power of half over 16 raised to the power of what? Half. 1 raised to the power of anything is 1. So that will be 1 over 16 raised to the power of half. What do you do next? Think of a number you multiply twice to get 16. And that will be 1 over 4 raised to the power of 2 times 1 over 2. This 1 over 2 here. And final answer becomes 1 over 4. Okay, so that's the size of the work for this morning. Lovely questions we've solved. And I'm trusting that you have gained something from our work today. We have these videos uploaded to we have these videos uploaded to YouTube regularly, so we trust that you go to YouTube, watch them, and enjoy yourself. And will you join us in our class tomorrow? As for tomorrow, we are going to be looking at geometry. Look at geometry, and if time permits us, we'll try to finish up this aspect. Have a wonderful day and keep solving maths.